Approximations. All dimensions, measurements are rounded off and are therefore subject to error. Least unit of measure is the difference between the lower limit and the upper limit. Absolute error is half of the least unit of measure. The notation modulus x means the absolute value of x. The absolute value of a number is the number without its sign. So, modulus positive 6 equal to 6 and modulus negative 6 equal to 6. The absolute error of a dimension is the absolute difference between the true measure or true value and the recorded value. Absolute error equal to the modulus recorded value minus true value. The relative value of a dimension is the ratio of the absolute error to the true value. Relative error equal to absolute error over true value. The percentage error states the relative error as a percentage. Percentage error equal to relative error times 100% or absolute error over true value times 100%. Tolerance is the difference between the greatest and the least acceptable measurements. 2016. The length of a wire is 5.2 centimeters correct to 1 decimal place. What is its maximum possible length? So since the question was given with 1 decimal place, our least unit of measure will be a 0.1. So we'll say least unit of measure equal to 0.1. Then we have to find the absolute error. The absolute error is half of the least unit of measure. So we'll say absolute error equal to half is the same as 0.5. 0.5 times 0.1 is giving us 0.05 centimeters. Therefore, our maximum possible length will be the length of the wire plus the absolute error. So we are going to say maximum possible length equal to 5.2 centimeters plus 0.05 centimeters. Maximum possible length is equal to 5.25 centimeters. 2017. Misozi and Filamba estimated the length of a line to be 9 centimeters and 10 centimeters respectively. If the true length of the line was 9.6 centimeters, find Misozi's absolute error. Find Filamba's percentage error. So we are going to start. Misozi's absolute error is equal to the modulus of the recorded value minus the true value. So Misozi recorded a length of 9 centimeters and the true length was 9.6. So we are going to replace. The modulus of 9 minus 9.6 is giving us 0.6 centimeters. So Misozi's absolute error was 0.6 centimeters. Filamba's absolute error was the recorded value minus true value, the modulus of the recorded value minus the true value. So Filamba's recorded value was 10 and the true value was 9.6. Filamba's absolute error was 0.4. The question is saying find Filamba's percentage error. So Filamba's percentage error is the absolute value, the absolute error divided by the true value times 100%. So we are going to say 0.4 divided by 9.6 times 100%. Filamba's percentage error was 4.17%. 2018. The length of a line is 8 centimeters. If this is recorded as 8.2 centimeters, calculate the percentage error. Absolute error equal to the modulus of the recorded value minus the true value. The recorded value was 8.2 and the true value was 8. So replace. 8.2 minus 8 is giving us 0.2. Then our percentage error is the absolute error over the true value times 100%. So say 0.2 divided by 8 times 100%. So the percentage error was 2.5%. 2019. The length of a piece of wire is measured as 4.5 centimeters. Calculate the tolerance. Calculate the relative error. So we are going to say tolerance is equal to greatest minus least measurement. So we'll have to find the greatest and the least measurement. So we are going to first find the least unit of measure, the absolute error, the upper limit and the lower limit, and then the tolerance. So we are going to say least unit of measure is 0.1 since we have one decimal place. Our absolute error is half of the 0.1. Half of 0.1 is giving us 0.05 centimeters. Our upper limit is the length of the piece of wire plus the absolute error. So our upper limit is 4.5 centimeters plus 0.05 centimeters, which is giving us 4.55 centimeters. And our lower limit is 4.5 centimeters minus 0.05 centimeters, which is giving us 4.45 centimeters. Our tolerance is therefore the upper limit minus the lower limit. So our greatest was 4.55 centimeters minus 4.5 centimeters, which is giving us 0.10 centimeters. Calculate the relative error. So we are going to say least unit of measure is 0.1. Absolute error is 0.5, which is half of 0.1. So we are saying 0.5 times 0.1 will give us 0.05. Our relative error is equal to the absolute error over the true value, which is giving us 0.05 centimeters divided by 4.5 centimeters. Our relative error is therefore 0.011.